Hello everyone! In this video presentation, we are going to discuss how computing can foster creativity in primary and secondary education. Generally, we are going to present arguments that creative thinking tools and computing can be used to support creative human endeavors and can be effective ways of moving education forward. It is not enough just to know how to work a computer. In order to become more creative, we need to understand how a computer works and how to make it work for us. Over the years, computing has made possible profound leaps of innovation and imagination as it facilitates our efforts to solve pressing problems. For example, the prevention of many diseases. It also expands our understanding of ourselves as biological systems and our relationship to the world around us. These advances, in turn, drive the need for educated individuals who can bring the power of computing-supported problem-solving to an increasingly expanded field of endeavors. It is no longer sufficient to wait until students are in college to introduce these concepts. Nowadays, we have access to powerful and interactive technologies which allow students to think in powerful ways and help awaken their creative thinking skills. The sooner these skills are awakened, the easier it will be for students to apply their creative expression to problem solving and develop new knowledge. As it is known, the pervasive nature of computing and widely available digital tools, for example Scratch, have long been used in an attempt to transform education system. Tools like Scratch can empower students to showcase their creativity like never before. However, the way these tools are taught by teachers and used by students significantly influences whether students move along the creativity continuum. In fact, Scratch has mainly been used just as a presentation tool, and most of the students did not fully explore its possibilities, including programming tasks, educational games, and animations. Moreover, while Scratch has been widely used, little is known about how it influences students' creative thinking. Creativity, or creative thinking in this case, can be simply defined as the acts of turning new ideas into reality. The revolution in the education system came in 2014, when the new and first in the world national curriculum for computing was introduced in England. The rationale behind these changes was that computing fosters creativity by allowing individuals to move from merely being consumers of technology to building tools that can have a significant impact on society and economy. Teaching programming skills to children can be seen as a long-term solution to the skills gap between the number of technology jobs and the people qualified to fill them. Moreover, to emphasize the importance of creativity in computing, the College Board in America introduced creativity as one of the 7 big ideas as part of the new Advanced Placement Computer Science Principles course, which allows high school students to earn credit for college-level computer science course. As we previously mentioned, there are 7 big ideas of computer science, where creativity and algorithms are amongst them. The direct link between this topic and algorithms as a part of Comp 256 module will be explained in the forthcoming slides. Generally, algorithms are used to develop and express solutions to computational problems. To design an algorithm, not only do you have to have highly developed computing skills, but also be creative to precisely express a sequence of instructions so it can be executed by a computer. This is a skill itself. All of today's students will go on to live a life heavily influenced by computing, and many will work in the fields that involve or are influenced by computing. Therefore, they must begin to work with algorithmic problem solving and computational methods and tools during the primary and secondary levels of education in order to foster their creativity. Regardless of a discipline, it is a priceless ability that allows students to perceive the world in new ways. Creativity involves a set of thinking tools that overlap with fundamentals of computer science, which can in turn support the development of creative thinking. Among the tools that overlap, the following can be distinguished: observing, abstracting, imaging, and patterning. The ultimate goal should not be to teach everyone to think like a computer scientist, but rather to teach them to apply these common elements to solve problems and discover new questions that can be explored within and across all disciplines. Although the impact of computing on creativity is not easy to be directly measured, more specific definition of creativity is needed. Here, we can break down the definition into smaller components such as originality, novelty, and usefulness of a proposed solution to a given problem. In fact, there could be many more components, but it does not really matter at this point. In our opinion, to demonstrate how computing can foster creativity, it is worth paying more attention to the current computing curriculum and compare it to the previous one. It is also worth mentioning computational thinking, which is an umbrella term for computing and creativity. Generally, computational thinking is the thought process involved in formulating a problem and expressing its solution in such a way that a computer or machine can effectively carry out. This requires creative approach to computing. In the next slide, we are going to explain why primary and secondary school students should be taught these skills. We already know that computing revolutionized education system, but what about creativity, or more precisely computational thinking? The old information technology curriculum focused purely on computer literacy. It was all about teaching pupils over and over again how to word process, how to work a spreadsheet, how to use programs already creaking into obsolescence. The new curriculum teaches children computer science, information technology, and digital literacy in a more creative way, teaching them how to code and how to create their own programs, not just how to work a computer, but how a computer works and how to make it work for you. Generally, computing will allow students to experiment with new technologies and hopefully transform them from tool users to creative tool builders. In the end of the day, not everyone has to work as a computer scientist, but learning programming skills will benefit children in many other ways, whatever their ultimate career, almost akin to the reasoning for giving children the chance to learn a musical instrument or foreign language. It can be said that the basic idea of computing is to get a computer to solve a problem. In order to do so, you have to come up with a set of instructions that a computer will execute. If you can do that, it is a hugely valuable skill whether you are working individually or as a part of a team. Computational thinking is not about output, a smartphone, or another Watson-like computer. It's the ideas that inform our technology and lead to their creation. Algorithms are a crucial part of computing and computational thinking. Understanding algorithms stimulates pupils' creativity and encourages them to design their own ways of solving problems. It has to be indicated, however, that algorithms can be taught in many creative ways, even on a playground, which will be demonstrated in the next video. In the video, pupils using the pattern on the floor try to sort 6 numbers. Everyone starts in his or her own box. When they get to a common box, they compare their numbers. Then, smaller number goes to the left and the larger number goes to the right. When everyone does it at the same time, we have an example of a parallel algorithm without using a computer. The algorithm continues until everyone gets to the top of the network. If everything is done correctly, the numbers will be sorted increasingly from left to right. It is a great activity that not only develops teamwork skills, but also teaches foundations of computing and algorithms. Later, the pupils can try to implement this kind of algorithm during the computing labs. The sorting network activity can be an alternative way of teaching the basics of algorithms. As it is known, sorting algorithms are arguably the most commonly used. Even though there is general consensus that computing fosters creativity, computational thinking appears to have been the hot topic in many articles, which indicated that computational thinking should be brought to primary and secondary education. In order to do so, cooperation, for example, with British Computer Society is needed. Most of the students certainly already know how to think and problem solve, but computer scientists can help teachers to understand these processes as algorithmic and identify where actual computation and manipulation of data with computer may fit in. Computational thinking is an approach to solving problems in a way that can be implemented with a computer. Students become not merely tool users, but tool builders. They use a set of concepts such as abstraction, recursion, and iteration to process and analyze data and to create real and virtual artifacts. Computational thinking is a problem-solving methodology that can be automated and transferred and applied across subjects. The power of computational thinking is that it applies to every other type of reasoning. It enables all kinds of things to get done. For example, quantum physics, advanced biology, human computer systems, and development of useful computational tools.